Assalamualaikum warahmatullahi wabarakatuh, and hi to everyone. So today we are going to learn chapter 4, which is the title is Introduction to Organic Chemistry. Organic chemistry is the chemistry of compound that contain in the element of carbon. So this is the subtopic for Introduction to Organic Chemistry. 4.1 is molecular and the structural formula. 4.2 is functional group and the homologous series. 4.3 isomerism, and 4.4 reaction of organic compound. Okay, so next 4.1 molecular and structural formula. So this is the learning outcome for this subtopic. At the end of the lesson, students should be able to define structural formula, shows the structural formula in the form of expanded, condensed, and skeletal structure based on molecular formula. And the last one is classify carbons into primary, secondary, tertiary, or quaternary, and hydrogens into primary, secondary, tertiary, or quaternary. So next, we look at the definition of empirical formula. Empirical formula shows the simplest ratio number of atoms of each element in a molecule. The example for empirical formula are CH2 and CH2O, while molecular formula shows the actual number of atoms of each element in a molecule. The example for molecular formula are C2H4 and C2H4O2. So now we look at for the structure formula. So this is the definition for structure formula. Chemical formula which shows how the atom in a molecule are bonded to each other. The representation of structure formula are expanded structure, condensed structure, and skeletal structure. So after this, I will show you how to write the structure formula by using these three structures. Okay, so this is for the reminder. In drawing organic structural formula is the extension of drawing Lewis structure. So we need to recall what we have learned in last semester for chapter 4 in SK015. All atoms must be in zero formal charge for neutral molecule, and example of atoms that are usually drawn in organic structural formula with zero formal charge are carbon, which is carbon has 4 covalent bonds, nitrogen, oxygen, hydrogen, X is halogen atom, which is element in group 17, carbon with single bond and double bond, carbon with single bond and triple bond, and oxygen atom. Alright, so now we look at this expanded structure. What is expanded structure? Expanded structure shows all the covalent bond formed between atoms. Okay, so now we have one example, propane. So how we can write the expanded structure? So propane consists of 3 carbon and 8 hydrogen atoms. So this is the first carbon, which is attached to 3 hydrogen atom, and this carbon attached to the next carbon atom, which is second carbon, and this carbon atom is attached to 2 hydrogen atom, and the last carbon or the third carbon attached to 3 hydrogen atoms. So this is the expanded structure for propane. Okay, so the next example we have propene, which is propene is alkene. In the structure consists of double bond. Okay, so first carbon is attached to hydrogen atom. Okay, and then this carbon form double bond with the next carbon, and then this carbon attached to one hydrogen atom, and the last carbon is attached to 3 hydrogen atom. So this is the expanded structure for propene. Now we look at for ethanol with the formula C2H5OH, which is the expanded structure for ethanol is CH3, and then we have CH2, this carbon attached to 2 hydrogen atom, and carbon attached to oxygen, and oxygen is attached to hydrogen atom. Okay, so this is the expanded structure for ethanol. Okay, so the next example is propanol with the formula of C3H6O. Okay, so first carbon is attached to 3 hydrogen atom. Okay, and then the second carbon is attached to 2 hydrogen atom. Next, we have carbon double bond with oxygen and also single bond with hydrogen. Okay, so this is the expanded structure for propanol. Okay, for the next example, we have 2-chloropropane, which is at second carbon there is 1 chlorine atom. Okay, so first carbon attached to 3 hydrogen atom, second carbon attached to 1 hydrogen atom and 1 chlorine atom, and the third carbon attached to 3 hydrogen atoms. Okay, so this is the expanded structure for 2-chloropropane. And the last one for expanded structure is N-methyl-methanamine. The formula is C2H5NH2. So first carbon is CH3. Okay, so this carbon is attached to nitrogen. Okay, and then this nitrogen is attached to 1 hydrogen atom, and the second carbon is attached to 3 hydrogen atom. Okay, so this is the expanded structure for N-methyl-methanamine, which is in the structure we need to show all the covalent bond between carbon and hydrogen, carbon with nitrogen, and also carbon with hydrogen. Alright, so this is expanded structure. Okay, the second structure is condensed structure. So what is condensed structure? Condensed structure does not show the single bond between carbon and carbon bond except for the cyclic, which is for cyclic we need to show the bonding between carbon and carbon. Okay, and then carbon with hydrogen bond. Okay, and then we need to show all the double and triple bond, which is C double bond C and C triple bond C in the structure. Okay, all hydrogen atoms that are attached to carbon are written immediately after the carbon. So in condensed structure, after we write the carbon atom, so we need to write hydrogen atom after carbon to show the bonding between carbon and hydrogen. We need to use bracket in condensed structure to show the here atoms, functional group, alkyl group, and the side chain, and also to indicate the repeating structure. Okay, so this is the example how to write the condensed structure. We have propane with the formula of C3H8. So from the expanded structure, now we want to convert into condensed structure. Okay, so this is CH3. Okay, carbon attached to 3 hydrogen atom, so we write CH3. The second carbon is CH2, and the third carbon is CH3. Alright, so this is the condensed structure for propane. Okay, so the next one is propene. Okay, and then propene has double bond. The first carbon is CH2. Okay, and then have double bond here. So we write double bond C, and then this carbon attached to hydrogen CH, and the last one is CH3. Alright, so this is the condensed structure for propene. Okay, so the next example is ethanol with C2H5OH. So from the expanded structure, So now we convert into condensed. Alright, so CH3, CH3, and then this is CH2, CH2, and then OH. Alright, so this is the condensed structure for ethanol. And the next one is propanol, C3H6O. Okay, from the expanded structure, convert into condensed. Okay, so this is CH3, CH3. This is CH2, and the third carbon attached to oxygen with double bond and hydrogen. Yeah, so we just write CHO. Okay, so this is the condensed structure for propanol. Okay, next is 2-chloropropane from the expanded structure. Look at the second carbon, there is one chlorine atom, so we need to put bracket. Alright, so first carbon is CH3, CH3, second carbon is CH, okay, and put bracket chlorine and CH3. Okay, so this is the condensed structure for 2-chloropropane, and the last one is N-methylamine. Alright, so from the expanded structure, so now we convert into condensed. Alright, so this is CH3, CH3, and then this is NH, NH, and this is CH3. Okay, condensed structure for N-methylamine. Okay, and for the third structure is skeletal. Skeletal shows only carbon skeleton. Alright, so carbon and hydrogen atom are not written. So in skeletal structure, we didn't write the carbon and hydrogen atom. Other than hydrogen atoms such as oxygen, chlorine, nitrogen, and etc. are shown. The bond in skeletal structure represent as line. Okay, so the skeletal can be represented by line. For single bond, only one line. Double line for double bond, and triple line for triple bond. Okay, so look at this example, how to write the skeletal structure. Let's say we have propane, C3H8, from the expanded. Okay, so we want to convert into skeletal. So starting from here, this is first carbon, CH3. Okay, so this point is CH3, and then this is CH2, the second carbon, and the third carbon is CH3. Alright, we didn't show the carbon and hydrogen atom, just use line to show the bonding between carbon and hydrogen. So this is the skeletal structure for propane. The next one is propene, CH2. Okay, CH2. Okay, and then this carbon form double bond. We write another single line here to show double bond. So this is CH2, CH2, and this is CH3. Okay, so this is skeletal structure for propene. The next one is ethanol from the expanded structure. So first carbon is CH3, this point is CH3, and then we have CH2, and this carbon attached to OH. Right, so this is skeletal structure for ethanol. And the next one is propanol. Propanol, okay, CH3, first carbon, okay, CH3, the second carbon, CH2, and this carbon attached to one hydrogen atom and double bond with oxygen. Alright, so this is the skeletal structure for propanol. Okay, and the next one is 2-chloropropane. Alright, so this is the expanded structure. Now we convert into skeletal. Alright, so this is the first carbon, CH3, and then second carbon attached to hydrogen. Okay, and then chlorine, we need to write chlorine, and the last one is CH3. Alright, so skeletal structure for 2-chloropropane, and the last one is N-methylamine. Okay, from the expanded structure, we have CH3, CH3, and then this carbon attached to nitrogen, so write the nitrogen atom, and the second carbon is CH3. Alright, so this is the skeletal structure for N-methyl methanamine. Okay. Alright, so this is the example how we can write expanded, condensed, and skeletal. Okay. The first one we have C4H10O is ether. Alright, so this is ether. Okay, so this is the expanded structure. In expanded structure, we need to show all the covalent bond between carbon and hydrogen, carbon with carbon, and carbon with oxygen atom. So this is the expanded structure for ether: CH3, CH2, O, CH3, SCH2, and CH3. Alright, so in condensed structure, we just write CH3, no need to show the bonding between carbon and hydrogen, CH2, O, CH2, and CH3. Alright, so the next one is skeletal. Okay, just write the line. So this is CH3, CH2, alright, from the expanded, yeah, oxygen, okay, and then CH2, and the last one is CH3. Okay, the second one is cyclobutane. So this is for the cyclic compound, which is C4H10. In cyclic, there are 4 carbon atoms. Okay, so each carbon atom is bonded to 2 hydrogen atoms. Yeah, so we need to show all the bonding between carbon and carbon in the cyclic, and also carbon with hydrogen atom. Alright, so this is expanded. For the condensed structure, just show the single bond with carbon and carbon in the cyclic. Alright, and for skeletal, just write the square shape. Okay, no need to write carbon and hydrogen. So this is the skeletal structure for cyclobutane with formula C4H8. Okay, the next example is cyclohexene. Okay, with formula C6H10. Okay, so this is the cyclic compound. So in the cyclic, there are 6 carbon atoms, which these 2 carbon form double bond, and each carbon atom attached to 2 hydrogen atom, except for this carbon, yeah, which each atom attached to 1 hydrogen atom. Okay, so in expanded structure, we need also to show the bonding between all the atoms. Alright. Okay, for condensed structure, we just show the bonding between carbon and carbon in the cyclic, and also double bond. And for skeletal, just write the hexagon shape and put double bond. Alright, so this skeletal structure for C6H10 for cyclohexene. Alright, for the next example, we have carboxylic acid with the formula C3H6O2. So this is CH3, okay, CH2, C double bond O, O, and H. Okay, and then in condensed structure, okay, CH3, CH2, COO, H. And then for the skeletal, just write line here. Okay, to represent CH3, CH2, C double bond O, OH. Alright, so this is the skeletal structure for carboxylic acid. Now we look at one example for the past year UPS question for year 2007 and 2008, which is the question is convert the following structural formula to skeletal structure. So given the condensed, so now we want to convert into skeletal. So this is the cyclic, yeah, which is consists of 3 carbon. So in skeletal, we just write the triangle. Okay, so this is CH, CH, C double bond O, C double bond O, CH2, 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 and then OH. Right, so this is the skeletal structure for this compound. Okay, so the next one is classification of carbon. So in classification of carbon, only involve the saturated carbon, which is sp3 hybridized carbon, means that the carbon only has 4 single bond. Carbon can be classified as primary carbon, which is the carbon is bonded to one carbon atom. Secondary carbon, which is the carbon atom is bonded to another carbon atoms. Tertiary carbon is carbon atom that bonded to another 3 carbon atoms. And the quaternary carbon is the carbon atom that bonded to another 4 carbon atoms. And for hydrogen atoms, can be classified as a primary, which is hydrogen atoms is bonded to primary carbon. Secondary hydrogen is hydrogen atoms that bonded to secondary carbon. And the tertiary hydrogen is hydrogen atoms that bonded to tertiary carbon. Okay, a primary carbon is directly bonded to one other carbon atom, which has one adjacent carbon atom. So now we look at one example. Okay, so this carbon atom is primary carbon because this carbon is bonded or attached to one carbon atom. And then these 3 hydrogen atoms are primary hydrogen because they are bonded to primary carbon. And this carbon is primary carbon because it is attached to another 1 carbon atoms. Okay, so next is a secondary carbon. Secondary carbon is directly bonded to 2 other carbon atom or has 2 adjacent carbon atom. Okay, look at this example. Okay, this carbon is secondary carbon because it is attached to another 1 carbon atom. Okay, and then this carbon atom also attached to another 1 carbon atom. So there are 2 carbon atom. So this carbon is secondary carbon. These 2 hydrogen are secondary hydrogen because it is attached to secondary carbon. And this is primary carbon because it attached to 1 carbon atom. And this is also primary carbon because it attached to primary carbon. A tertiary carbon is directly bonded to 3 other carbon atoms, which has 3 adjacent carbon atoms. Okay, look at this example. This carbon is tertiary carbon because it is attached to another 3 carbon atom. And this hydrogen atom is tertiary hydrogen because it is bonded to tertiary carbon. And this is primary carbon because it is attached to 1 carbon atom. And this is also primary carbon because it is attached to 1 carbon atom. And this is also primary carbon because it attached to 1 carbon atom. Okay, the next one is quaternary. Quaternary carbon is directly bonded to 4 other carbon atom, which has 4 adjacent carbon atoms. Look at this example. Okay, this carbon atom is quaternary because it is bonded to another 4 carbon atom. Okay, so now we look at this example. Okay, so this is primary carbon, this is secondary, and this is also secondary, primary, primary, primary and also primary carbon. Okay, and then this is tertiary carbon because look at the structure, it is bonded to another 3 carbon atoms. And this is quaternary carbon because this carbon atom is attached to another 4 carbon atoms. Okay, next, this is the example. Okay, so this is primary carbon. This is primary carbon. This is secondary carbon. And then this is tertiary carbon because it is bonded to another 3 carbon atoms. And it is not an sp3 hybridized carbon. So we cannot classify these 2 carbon atoms. Okay, so look at this exercise. Classify each carbon as primary, secondary, tertiary, or quaternary. Okay, so this is the answer. So this is primary because it is attached to another 1 carbon atom. So this is primary because it is bonded to 1 carbon atom, and this is primary carbon atom. So this is quaternary because this carbon is attached to another 4 carbon atom. And this is secondary, tertiary because it attached to another 3 carbon atom. And then this is secondary, primary. And this is also tertiary because it is bonded to another 3 carbon atoms. Okay, so this is primary and this is primary carbon atom. Okay, so this is the past year UPS question in year 2006-2007. Okay, so look at the question. Label and state the number of primary, secondary, and tertiary carbon in the following molecular structure. Okay, so refer to this structure, we need to label all the primary, secondary, and tertiary carbon. So look at the example, look at the answer. Okay, so this is primary because this carbon attached to 1 carbon atom. Okay, so this is tertiary. Okay, because this carbon is attached to another 3 carbon atom. So this is 1, 2, 3. Alright, and then this is secondary carbon because it is attached to another 2 adjacent carbon atom, and this is primary. So number of primary carbon is 2. Okay, by referring to this structure. Number of secondary carbon is 1, and the number of tertiary carbon is 1. Alright, so that's all for subtopic 4.1. Thank you.